Hello students, I am Pinakapani. Today I am going to discuss an optics experiment with you.
Coming to the aim of the experiment. The aim of the experiment is to calculate the dispersive power of the material of the materials that are required for the experiment are spectrometer, prism, mercury vapor lamp, and spirit level. Coming to the basic thing, what is a spectrometer? Spectrometer is an optical instrument used to study the spectra of different sources of light and to measure the refractive indices of material. Basically consists of three parts. They are polarimeter, prism table, as well as telescope. Polarimeter is an arrangement to produce a parallel beam of light. It consists of a long cylindrical tube, a convex lens at its inner end, and a vertical slit at its outer end. The distance between the slit can be adjusted such that the slit is focused on the lens. Coming to the prism table. It is used for mounting the prism or grating, etc. Consists of two circular metallic discs provided with a three leveling screw. It can be rotated about a vertical axis, passing through its center, and its position can be read with the vernier scales V1 and V2. The telescope, as everyone knows, it's an astronomical tool. It consists of an eyepiece provided with a crosswire at its one end and an objective lens its other end coaxial. The distance between the objective lens and the eyepiece can be adjusted such that the telescope forms a clear image at the crosswire. Let us understand the theory behind the experiment. When a ray of light is reflected by a prism, the angle between incident and the refracted ray is called the angle of deviation. The angle of deviation is maximum when the angle of incidence and the angle of emergence, that is I equals R, and it is minimum depends on the wavelength light used. The refractive index of the prism for a given wavelength of light lambda related to corresponding delta m by this formula, that is sine of a plus delta m by 2 divided by sine of a by 2. Now let us understand the experiment.
This apparatus is known as spectrometer as we have discussed in the earlier slides. This is the part of telescope and this is prism table and this is collimator. As we have discussed in the earlier slides, in this experiment we will have three parts. That is finding the angle of prism and finding the direct ray reading as well as finding the angle of minimum deviation. So first we will study how to find the angle of prism. For the angle of prism, place the prism in such a way that the side or face AB and face AC should be focused in such a way that the light which is coming from the collimator should reflect from these sides and opaque side should face towards. After placing the prism as discussed, move the telescope or rotate the telescope in such a way that you will see the slit or the reflected light on sides or faces of AB as well as AC. Now we have adjusted the telescope in such a way that you can see the slit. I am just focusing. You can see the light as well as the slit. Now take the readings of this vernier V1 and vernier V2 and now we have adjusted it to the other side of the prism. Now you can even see the slit from this side as well. Now even take the readings from vernier V1 and V2. Note it down. Here is the table comprising the values that we have acquired during the experiment. In vernier V1, since we have moved the telescope in anti-clockwise direction, we will be adding the values of right and left to acquire 2A. But whereas in V2, it has moved in clockwise direction, we will be taking the difference of right and left to acquire 2A. For finding the second part, that is the directory reading, remove the prism from the prism table and then adjust the telescope in such a way that you can see the direct ray or the light that is emitting from the collimator. See, like this, the light will be appearing from the telescope. These are the direct ray readings that are verniers V1 and verniers V2, that is right side and left side. For finding the third part, replace the prism and adjust it. Adjust the telescope, like moving it towards the opaque side or opaque face to see the spectral lines. Now you can see the different spectral lines or 7 colors in the telescope. After seeing the spectral lines in the telescope, the key point will arise. There you have to rotate the prism table such that the spectral lines will move in a single direction, and at a point it will retrace its path. Now we'll rotate. See, at this position it is retrieving back, so stop at this position and start recording the spectral lines. After the adjustment of the telescope, now you just point the crosswire of the telescope on each color and then take down the readings of Vernier scale V1 and V2. In this table, we can see the Vernier scale readings of each color, and to acquire L and R of each color, we have to subtract the left side reading of the direct ray reading from the left side reading of the color, and for R we have to subtract the right side reading of the Vernier scale reading of direct ray from the right side reading of the color. And for angle of minimum deviation, it is L and R divided by 2. In this table, we can see the values of mu that we have calculated for different colors using the formula sin A plus delta by 2 divided by sin A by 2. Now you can see the calculation of dispersive power, that is using W equals mu2 minus mu1 by mu minus 1, where mu2 is the refractive index of violet color, whereas mu1 is the refractive index of red color and mu is the refractive index of yellow color. So finally we acquired the result, that is the dispersive power of the material of the prism is found to be 0.075. The precautions that should be taken in this experiment are: the prism table should be straight. With the help of this spirit level, we'll check whether it is straight or not. See, you can see the bubble is in the middle, so which means it is in the straight. The second one is, never hold the prism on its faces, just hold it on top as well as on bottom. Hope you understood the video. Thank you for watching.